Hey, good morning, everybody. So what I'm doing here is I'm showing you a video on how to do scatter plots. So when you run a correlation analysis, you're looking at the relation between any two variables. So we pick the variables and we can run correlation in SPSS using our usual analyze function. So I'm taking out, excuse me, I'm working with a very specific data set here from a different study I'm conducting, and I'm doing for this video I'm just showing you how to do a simple scatter plot, and I'm just using continuous variables. I'm not using any categorical variables, just plain old scatter plot with continuous variables. So let's start. So I picked I'm going to pick a set of variables that I'm interested in. Go to my correlate function. I'm doing bi-variate here. Excuse me. I apologize for that. I think I have a little bit minor cold. So I picked up a certain set of variables here, and all of them have a little ruler by them indicating that they're continuous. I picked the SHAPS variable. This is actually just so I'd like to tell you what these variables mean. Anyway, this is variable that measures anhedonia, or inability to experience pleasure. BAI is an anxiety score, Beck's anxiety inventory, PANAS score, positive and negative affect scale, and this is for negative affect, which means negative emotions, right? YPrep is a preparation for quitting smoking, and this is a depression inventory. Okay, so we have 4 different items here. Of course, I'm just picking a Pearson correlation here and nothing else, so I'm going to have a correlation matrix prepared for me, and I'm just looking at some stuff here that I don't really care about here. And I'm going to, it's two-tailed test, right? And so it flags significant correlations, so it'll show me which ones are significant. Here's our nice little table of correlations. Okay, so you'll see in any correlation matrix you always have, and it's called a matrix, right? A correlation matrix has 2 interesting characteristics. One is it's symmetric, right? It's symmetric. It means what's on the top is equal to what's on the bottom underneath the diagonal, and the diagonal is 1 because a correlation is a standardized covariance matrix, right? You know, when we talk about calculating correlations, we took the covariance and divided it by the standard deviation of the 2 variables, right? So that's called standardization. So when we standardize these variables, it has a standard deviation of 1, right? So this, in any, usually this is what's known as a variance covariance matrix, and you'd have the covariances down the diagonal, but because this is standardized, they're all 1s. And because this is symmetric, we could look at any half, the top half or the bottom half, so they're repeated. Excuse me. So here let's look at the SHAPS variable. The SHAPS variable, as you can see from the two-tailed p-values, isn't correlated with anything significantly, and those correlation coefficients are kind of low anyway. So the anxiety inventory, on the other hand, has some significant correlations, like it's significantly correlated with negative affect, which makes sense. People feel pretty bad about themselves once they are I guess if they have anxiety, they feel very negatively. And then also depression and anxiety are considered basically highly comorbid, and you can see here, so is the preparation to quit. Apparently people who are anxious are prepared to quit smoking. So there's just some correlation. So let's go ahead and draw some of these matrices here, scatter plots. Okay, now I showed you how to do this already. I showed you how to do graphs already when we did the initial chapter, when we had to do our first assignment, which was descriptives. So you can just work with that, right? Going through Chart Builder. And it's important to note that often the answers aren't evident. So some of you may have said, and I saw this in some of your comments, like, you never showed us how to do this. Well, no, people haven't shown me how to do a lot of things either, and I figured them out. Part of being in graduate studies is that you have to be able to figure out things for yourselves. Okay, we certainly want to provide you with all the information possible, but you have to be able to figure things out for yourself too. That's what will separate individuals who in the end are extremely successful from those who are just moderately successful. The most successful individuals can find things on their own. Okay, I showed you how to do this part already. Now if you look through the types of graphs here, you'll see it's scatter plot. It's listed right there. So this isn't, I'm going to reset this because I already ran something. So you have your bar charts, whatever you want, your scatter plot. I'm going to take this, and I showed you how to do this already, and drag this in here. And again, it wasn't necessary, it may or may have not been with scatter plot, but it was definitely with bar charts, etc. So we're going to stick the two variables we're interested in here. So let's see what I'm looking at. One reason I really hate using this drop down versus writing code myself, because it's so hard to find the variables. You have to go through this whole thing and look. And this is a small data set. Sometimes you have data sets that have thousands and thousands of variables in them, and this would be just ridiculous. So here's this depression variable. Generally we would put the x variable down here and the y variable up here. The y variable is synonymous to the outcome. So put this in here. Okay, so this is your depression. Now let's do anxiety. Or we could do negative. Well, let's do negative affect. Those two should be related strongly, I think. Okay, and let's see. There's other options here. I'm not worried about any of those right now. Because once we run this, we can actually add stuff to it. Okay. And let's just statistics. What statistics do we want? Well, we probably want the. I'm not going to do that. Display error bars. Let's just hit OK here. So you have your. Oh, look at this one. You see, you have a very nice looking scatter here. Now you'll notice that there's a lot of disparity around here, right? Or a lot of variation. So there's going to be these points represent the nexus of two values, confluence of two values, the crossing of two values, intersection, that's the word I'm looking for, yes. Intersection of two values, right? So you'll notice that they tend to have this really nice linear function, right? And it's not always going to be like that, but there's a lot of disparity. They're not all centered perfectly around a line. Now, if I double click this, I can add stuff to it. Okay, like I can, for instance, add, let's see, add a line, add fit line, add total. We don't want that kind of line. Let's just add a fit line here. So here's, it's like, this is like a little, this is like a little regression line. So it actually, see how it's y equals, so you have an intersection point, and then you have a beta. So we have that anyway, so it's really cool. Let's see, anything else we want in here. You can doctor it up if you want, whatever. And this will give you an r² value too. Okay. So there you go. That's a scatter plot, and this is a nice one. Let's look at another one that might not be so nice. Let's try another. So go up to graphs. We're still dealing with chart builder, and we have depression. Ooh, let's try positive affect instead. Let's get rid of this negative affect and see if we can find positive. If everything is right, they should be negatively related. And notice how I say it should, because you never know. One never knows what's going to happen in the world of data analysis. Let's put this here. Okay. Let's hit OK. There you go. So this is negatively correlated. Again, there's a lot of spread here, but this seems to be going from top to bottom, from left to right, in this negative direction. So again, we can add this lead line just to see what it looks like. Fit that line and see, there you go, it's going down. Let's see, what is it? Display, spike, suppress, quadratic. It's linear, so that's what we're using. percent of points fit, confidence intervals, we don't have any, we don't want one. You could do a lot of things. So, but here again, the R squares are going to be R squares, so that doesn't matter if it's negative or positive because you just square it and you get rid of the negative sign. And there you go. So here you have a nice table, a nice figure. You can always copy and paste this figure into your, oh look, if you right click here, you can add other stuff, whatever you want to do, but you can copy and paste this into your homework assignment. Some of you asked me like, but Professor Rodriguez, you said I don't want to see any SPSS output in your assignment, but you're asking me to copy and paste this figure in here, isn't it? This is the stuff that I don't want to see. This stuff here, I don't want to see any of that. I don't want to see stuff like this. I don't want any of that stuff in there. That's what I mean by SPSS output that I don't want. Figures, I mean, how else are you going to make the figure? Okay. All right, just to wrap things up here, again, I want to make sure that all of you understand what my perspective on learning is. Learning involves a lot of trial and error. To become an outstanding learner, I'm not talking about knowledge, I'm talking about learning. To become an outstanding learner, one has to go through all the trial and error, and one has to fail many, many times to be successful. In fact, we fail way more than we are successful. If I use an old biblical story, I could say it's better to teach people how to fish than to give them fish, right? Because fish will feed them for one day. Teaching people how to fish will feed them for a lifetime. So that's the same kind of thing with higher education. You have to work really, really hard, and you have to fail many times. If you expect people to spoon feed you with stuff, yeah, you might do well in that class, but then that's not going to help you in your job. In the real world of work, you get a lot of tasks to do that are impossible. Some of them are literally impossible. My first stats job ever was working for Western Union, and I worked for somebody who kept on asking me to do something that was impossible, and I spent hours and hours on it. This was prior to the kind of computer abilities we had now, and I was using SAS, and maybe I was using SPSS, but we didn't have the capability to do the work that was asked at that time. This was back in probably 1985 or so. So we didn't have the capacity to do the work that we can do now. But now, if you ask me to do something, and I get asked to do stuff all the time that are really complicated. Like, for instance, I got asked to provide a sample size calculation for a company I'm working for as a consultant. That job was actually very, very difficult. So I went through the literature, I went through different websites for different computer programs, and I figured out how to do something that there was no instructions for. So that's the way things work, and I did it really quickly. And the reason I did it quickly is because I focused on the fact that I don't know what I'm doing at that moment. And I got to figure it out fast, because people rely on me to do that, and my reputation's on the line every time I'm asked to do something. So you figure it out. I was talking to my undergrad students about this in EPI. I said, you got to earn your competence. You earn it through failure. And I equated it to what was going on with the self-esteem movement. I came out of the Department of Education at the University of Maryland, and one of the problems we had back when I was a graduate student was that people believed that we should give people high self-esteem and then they'll do well. But that was a complete error. It goes the other way around. You have to do well in order to earn self-esteem. Self-esteem by itself is nothing. I mean, some of the worst people in the world have high self-esteem. So you have to earn it. You earn it through going through trial and error. So I'd prefer a person working for me any day who can fail a lot and work her way out of that than somebody who has high self-esteem but basically is incompetent. Okay, so that's my my little message for today. All right, we should be good to go. Have a good day. Have a good weekend and Thanksgiving. Happy Thanksgiving.